Alright, ratios. It's a pretty interesting topic. Ratios are awesome, and I'm just going to talk about them for a little bit. Okay, so what we're going to do here is we're going to look at the content. We're going to define ratios. We're going to look at scenarios which use ratios. A few other examples as well. So definition. I'm going to put links in the end and in the description as to where I found this information. There's going to be more questions there, which is useful. I really recommend you look these up. Okay, so basically this is the definition of a ratio. It just shows how much of one thing is compared to another thing. In this case, it's just 2:3 of these monsters. The blue ones, there's 2, and the red ones, there's 3. Pretty simple. So the ratio here would be 2 blue monsters is to 3 red monsters. We can look at a different example of the ratio of girls to boys in a classroom. In this example, we have 3 girls is to 1 boy. You can choose to look at this in different ways. You can write this as 3:1, 3/1, that being 3 girls per 1 boy. Or you can write it in words, 3 divided by 1, being for every 3 girls you have 1 boy. You can look at it the opposite way, boys to girls. In this way it will be 3 boys, 1 boy, that is my mistake, to 3 girls. Alright, and the other ways you can write this down would be 1:3, a third, that is 1 boy per 3 girls. Or you can say 1 divided by 3 in words. Now, the total number of students in this example, here we just have them all mixed up, is 4. Because you have 1 boy here and the 3 girls, and combined the number of students in this class, which is a very small class, is 4. Now, you could reverse this and say, what is the number of girls per students? That will be 3:4. For every 4 students, well, in this case, there'll be 3 girls. And for every 4 students, there'll be 1 boy. It's just the same ratio as that one. It just depends on how you choose to look at it. So that's an important thing. When you're dealing with ratios, always know what's the relationship within the ratio, like what is to what is being represented. Okay, so here's an example question. Imagine now you have this same ratio is true in this case. Let's just say that the people that choose the students choose 3 girls first, then 1 boy, and then they continue using this method to choose students. Now the example says 500, so that'll be pretty difficult to deal with people, but we'll just measure how many students, like the ratio of students that will be in this classroom. So since the total is 500, we know that each a unit in this case would be 4, but I'll explain what that means later. So we'll come back to this question and then I'll explain how to solve it once we've gone through everything so that it's not too confusing. Okay, so here's a hint. But we'll come back to this. I'll come back to it. Okay, a different example is sharing money between 2 people. So you have an amount of money and then you want to give it to 2 people. Alright, so our 2 people here, Jack, Joe. The ratio of sharing is 5 to 7. So for every 5, so this is a different example with ratios now, it's just sharing money. So for every 5 that Jack gets, Jill gets 7. And while this condition is true, we can give them £12. So here we've given them £12. So how much do they share between them? So because the ratio was 5:7, we're gonna give Jack 5, Jill 7. Total of the money is 12. So the money is split between them. There's no change. Now say in a different example, we share £25. After £25, what's going to happen is the ratio is going to remain the same. So for every 5 Jack gets, Jill gets 7. So how much do they share between them? Jack gets 10. Jill gets 14. Now we can look at one method of working this, and we know that our ratio is 5:7, where the total is 12 for the £12. When it was £24, if Jack gets 2 5s, Jill gets 2 7s, the ratio is still 5:7. The ratio here, 25:35, if there's £65. If we divide this by 25, if we divide 25 by 5, we get 5. If we divide 35 by 5, we get 7. So the ratio remains the same. In the case where there was £61, that means that Jack would get 25, Jill would get 35, and there'll be 1 that remains. The £1 that remained will have to be broken down into pence. And the pence will be shared using the same ratio. What's going to happen is that 25 pence, 35 pence, there's going to be 40 pence left. Of the 40 pence, they can either choose to return it back, or Jack can take 10 pence, Jill can take 14 pence, and they keep breaking down the ratio. Here's an example of the amount that they will have to share. In this case, be 12 pence. Jack gets 5. Jill gets 7. So you see Jack in this case always gets less than Jill. Because of the ratio, Jill will always get more than Jack. Now let's say they're not sharing money in this case. Also going back just on this one. Whenever you solve a ratio, in this case, like for example, you know that Jack, the ratio is 5:7, and you didn't know this was 7, and you know this is 50. Because this one increased by 10, this one will have to increase by 10. 50 to 70. The total will also increase by 10. So you can see 5 times 2, 10 here. 7 times 2, 14. The total times 2 will be 24, which is also equal to 14 plus 10. So the ratio and the total that is shared between them, and the ratio of sharing, will always be the same. So that's another way of looking at ratios. Also, if you look here, if Jack has 500, because the ratio is 5:7, the 5 increase multiplied by 100 to give you 500. So if you divide, the simplest form is always 5:7. So that's what we call the simplest form. In this case, this is a scenario where Jack has 500, and if the ratio is always the same, then Jill is to have £700. The total between them, you'll have to measure that on paper so you can pause and do the calculation. But your total, you can, in this case, you can say 700 plus 500. Or you can say 100 times 12. But the best way would be to add these two, as the money is shared between Jack and Jill. Now we're going to look at a scenario where pizza is shared. We now have Shelly and Kat. For every one slice that Shelly gets, Kat gets 3. So the total slices shared would be 4, and the ratio is 1 pizza slice for Shelly is to 3 pizza slices for Kat. So now our ratio is 1:3. When there is 4 slices, Shelly gets a quarter, Kat gets 3/4, but the ratio is always 1:3. So that's one way of looking at it. What happens if we increase the number of pizzas that they order? Say they order 400 pizzas, 400 pizza slices to keep it constant. Out of the 400, for every one that Shelly gets, Kat gets 3. So in this case, what's going to happen is that you want to find what 1 share of a pizza is. This is basically the unit of sharing, or if you want to describe it in a different way, you could say how much is 1 represents like 1 share, and of every share of every total shares, basically Shelly gets 1 share and Kat gets 3. So you find the unit share in this case. If you want to use that kind of a calculation, you'd say 1 share of a pizza is 100 pizzas. And how you get that is that share, we know that share is going to be equal to the total to be shared, in this case, which is 400, divided by the sum of the ratios, which was 4. And then that's what 1 share is worth. So in this case, since Shelly is getting 1 for every 3, Shelly gets 100 slices, and Kelly gets 300, which is 3 times 3 shares. And we know that 1 share is equal to 100. And then we have 3 times 100 to get the total that Shelly gets. And if you add 100 plus 300, it will give you 400, which is the total pizza slices in this case. And 1 share is 100 slices in this ratio. If the ratio was 2:3, then that would change. If it was 2:2, which would be 50-50, 1 share would be represented by 100 pizzas. And because both of them are getting 2 shares of a total of 4, which is 2 out of 4, that would be 200 pizzas, 200 slices of pizza each. Alright, best way to look at this would be to practice the questions that are in the links that I'm going to put in the end of this presentation, and of course at the end of the this is the description. Alright, so we have pizza slices here. Shelly gets 1 share for every 3 shares that Kat gets. Also, you can calculate the share saying amount that Shelly gets divided by ratio value for Shelly, which is 1. The same is true for Kat. The share for Kat will be total amount of pizzas that Kat gets divided by the ratio value for cat, which would be 3. But there's different ways of calculating ratios depending on how you like to do calculations. It depends. But this is one way I've come across by defining the simplest ratio and finding what a unit share would be like. Okay, so after you finish solving a question, you could ask yourself, how do I find out if my answer is correct? Like, if you're supposed to simplify the shared amounts, for example, if you're expanding them, like if in this case, if the ratio for Jack and Jill, going back to Jack and Jill, was 5:7, and you're only given 500, what would Jill have? Your final answer should divide by, or should simplify back to 5:7, which was the simple ratio between them. So this is just basic ratios, not going too far. Okay, do you get the original ratio if you break down by dividing with common factors? Multiples. Alright, do practice with more questions. Like if you just look up worksheets, you can practice those. They have answers. So that's the best way to revise ratios. Now the person getting less in the ratio should always get less when you find your total amount. So just going back, I think I mentioned that over here. You know that Jack was getting 500. Jill was getting 700. So Jill should always get more than Jack because it's not a 50-50. The reasons for the ratio, who knows? But that's the rule, that's the condition, and it should be respected. Alright, okay, so if you answer questions correctly, then you can pass. Another thing is, it's best to just go through the notes that I'm going to put in the description and practice the questions. What else was I was going to add? Alright, going back to the question that we left out, this one, the students. So you can try work out, like if there's a class of 500, how many students would be there in total? You can pause and try, but it shouldn't be too difficult. In the end, your boys to girls should be 3:4 when you do the calculation. Actually, no, the ratio should be 1:3 for one boy. You should get 3 girls after you did your calculation. And your final answer would be 125 boys is to 375 girls. And how you get that is you could use the share, you could divide 500 by 4 because that's the total number of students when you simplify the ratio. And then you know that 500 divided by 4 will give you 125. So that's the share. That's basically each group, each set within the students would be 120. Well, 500 divided by 4 will be 125. So you have one of the 125 being boys and 3 of the 125 being girls. And the ratio would be 125 is to 375, which simplifies back to 1:4 for the ratio of boys is to girls. Alright, I hope this helps. not everything like that is involved in ratios was talked about in here. For example, there's maps, and yeah, just like do like look into more sources of information and find the one that works the most. But I hope this helps. Goodbye. All right. So here's the map I was talking about, and you have your ratio here. Be 1 centimeter on the map represents 1 kilometer in real life, and here are the links. All right. Good luck.